Hey folks, welcome back. With software, we need a central point of control, sort of a foundation. So in this lesson, we're going to talk about Git and even a bit about GitHub. And we'll see in the upcoming section that AWS code commit can pretty much operate in place of GitHub. And code commit works with Git. So let's talk about Git, and it certainly won't hurt us to just understand the role of GitHub as well. Again, that role will be played in this course by code commit. So when we're talking about Git, we are talking about version control of our software. So it's going to help our software team manage changes to source code over time. So in our source code, we will have multiple versions of a software file maintained. And if an error exists in a current version, we can roll back to a previous version. And that rollback ability is certainly important, but of course, we need to move forward as well. So as we make changes to our code, we save those changes as new versions of our software files. And if you're talking about version control, it won't be long before Git comes into the conversation. Git is the most widely used modern version control system in the world. Git has a distributed architecture, and that means every developer's working copy of the code is also a repository that can contain the full history of all changes. And we'll take a look at a diagram here momentarily. Being distributed enables significant performance benefits as well. So remember, every developer can have their own working copy, and a developer can work offline from a main repository because they have the full repository locally. Just think about the implications of that. If for whatever reason you don't have an internet connection, well, you're not down. You have a local repository on your machine. And they're going to have a local repository, their own local repository, that they can change as they see fit and then merge back into a main repository. Okay, so what is GitHub? Well, Git is our version control system. So what is the hub? Well, the hub is actually a website, which we'll take a look at in just a second. It's a repository where development teams can store their projects. Each project has its own repository and unique URL where it can be accessed. So many Linux Academy courses use GitHub repository to store course files, such as CloudFormation templates and Python scripts, maybe Bash scripts. So in summary, Git is a revision control system, a tool to manage your source code history. GitHub is a hosting service for Git repositories. So Git is the tool, and GitHub is the service for projects that use Git. And the way this is utilized is usually GitHub can house your main repository for a software project. Well, let's take a step back. All right, so I've gone to a split screen here, and I'm at my own GitHub site. And you'll notice that there are a list of repositories. And basically, for coursework I have done at Linux Academy, such as CloudFormation Deep Dive, I have a repository, and that repository holds all of the code for a particular course. Now, CloudFormation is really heavy on the templates, so this is a fairly large repository. And notice a clone or download button. So again, this is GitHub, but anybody using Git who I have permitted can clone or download this repository and start making changes to these files locally. So in our diagram, let's take a step back and let's have a look at a diagram which kind of explains this graphically. All right, so again, GitHub can act as the main repository, and our development team can have local versions of a repository. We'll just use my site as an example. Any of these repositories, if I give team members permission, they can pull down a repository. They can work with it locally. They can commit changes. And when they're done, they can push it back up. Likewise, any of these other team members, again, assuming they have permission, can pull down the main repository, get the latest version, work with it, and commit it back to the main repository. And specifically, if we want to make significant changes, we can make a branch. So this is kind of a safe place for development. When you make a branch, that's in a sense your dev environment. You branch it off, you make your changes, and you're not hurting production because you're branched off. You're kind of a safe sandbox here. Now, when you ultimately want to commit this back into your main repository, there certainly should be sufficient testing on this new code, on a new feature, or maybe a bug fix. So again, one main repository, and then we can have many local repos. Now, you might see a problem arising here. What if two team members are working on the same file? Well, in a nutshell, we're going to have to merge those changes back to the main repository. And I'm not going to get too in depth with that because we'll certainly get in depth with that in the upcoming section on code commit. But a simplified explanation is that, again, let's say these two developers are working on the same file. So which version is going to be kept, or which changes are going to be kept? And that's where we have to go through a merge process. And again, don't worry about that. We'll have a full lesson on this merge process. So the pull and the push and the merge and branching, those are really the main steps when you're talking about working with Git and GitHub. One of the great advantages of code commit is that code commit is fully managed by AWS. So you don't have to worry about such things as server capacity and underlying management of servers. It's fully managed. Think about how RDS databases are fully managed by AWS, taking away a good bit of the administrative tasks that you would have to perform on servers. So that's a look at Git and GitHub, and that will provide us a foundation for moving into the code commit section. So I'm going to have one more short lesson in this section. We'll do a Git installation. So please join me in the next lesson. Hey folks, welcome back. So in this section, we're going to start working with code commit. And before we do so, we just need to do a few preparatory steps. And those steps include, we're going to set up an EC2 instance in the management console. And we're going to use this instance to communicate with Git and code commit. Now, code commit is basically AWS's managed version of Git. And the key word there is managed. So we get a lot of the benefits of AWS managing our repository for us. So again, the steps we're going to take, we're going to create and configure the EC2 instance. We're going to install Git on that instance. Having Git on the instance will enable us to communicate with code commit, but there's some IAM configuration that needs to take place. We need to configure a user and give that user code commit permissions. And finally, the way we're going to communicate with our code commit repository is via HTTPS. Now, there are two ways that we can communicate, HTTPS and SSH. And there's a bit more to it, but HTTPS is a bit easier to configure. HTTPS is ideal for the EC2 instance we will be using, and really only on a Mac. SSH is probably your better option because of some keychain issues, but for our purposes, we don't need to get too deep into the woods on that. We're just going to use it, HTTPS. So let's get started and knock out these prerequisites. Let's just go over to EC2. We want to launch an instance, and we're going to select Amazon Linux 2 AMI. T2 Micro is fine. Configure instance details. Let's just make sure that we can SSH into our server. So we'll enable auto-assign public IP. We don't really need to deal with any storage. Review and launch. And let's just create a new key pair. Now, one thing I want to point out about this is that you can certainly use the Linux Academy Cloud Playground to create your server. And I'll just call my key pair CC demo for code commit demo and download launch instance. And then we'll just go over and view and keep an eye on our instance. All right, while our instance is spinning up, let me talk about installing Git. So I'm showing 3 operating systems for installing Git, Linux, Mac OS, and Windows. And with Linux, I'm also showing the commands for Fedora, Debian, or Ubuntu. And of course, we're going to use Amazon Linux. Mac, you probably have it already, and then you just do git -- version. If you don't have it installed, it will prompt you to install it. And then Windows, most official build is available for download on the Git website. So I just want to go through those options briefly, but going to be focusing on our Amazon Linux box. Sudo yum install git. All right, so our new server is just about ready, and I'm just going to get the connection information so we can SSH into it. And I'm going to change the split screen so that we can SSH into it. All right, first thing I want to do is CD into my downloads directory. Then we want to do a chmod 400 on our key pair to change the permissions. And then we can use our SSH command, which we copied to our clipboard. Yes. All right. Usually says to run a sudo yum update. Let's go ahead and do that. All right, all set. I'll just clear the screen. And very simply, we can just run our sudo yum install git. There we go. And let's just check the version, but we know we had a successful install. There we go. All right, so we're ready to communicate with code commit, but we still have a few things to do here. Now let's set up the IAM configuration. I'll switch back to the AWS Management Console. All right, so let's check out our IAM configuration. And we just have a few simple steps. Create an IAM user for code commit. We're just creating an IAM user. What we do subsequently will give the user code commit access. We need to create and retrieve access keys for the code commit user. And then we're going to attach a code commit policy. So first things first, let's go over to IAM. All right, so let's just go ahead and select user, and let's add a user. And let's call our user Climber, because we're scaling a mountain here and we're going to succeed. And we can give this user programmatic access through the API, CLI, SDK. We're certainly doing that. And let's go ahead and give management console access as well. Note when we do that, it's going to auto-generate a password, or we can create one. I'm just going to go ahead and create one. Of course, when you do that, just remember what password you created. And I want that password, so I'm not going to require reset. Let's go to permissions, and let's attach a policy to our user. And as you might have guessed, we want to attach a code commit policy to this user. Now, if we were creating a group of users, we could just attach this policy to the group. So let's attach AWS code commit full access to our user. Next, tags, we'll just skip that, review, and create user. All right, so we've created our user. We've attached the code commit policy to the user, and maybe unbeknownst to us, our access keys have been created. Now, what we want to do is save these off somewhere, maybe in a little Word doc. Just realize this note here. This is the last time these credentials will be available to download. Sounds ominous, but however, you can create new credentials at any time. But save these off. You can show the secret access key and copy it. And we're just about ready to start working with code commit. One last thing we need to do is the HTTPS configuration. So I'm going to toggle on those instructions, and I'm going to switch back to my terminal window. All right, so basically when we are issuing commands to code commit from the CLI, this is our method of communication, HTTPS. That's how our commands are being transferred to code commit. Again, you can also do SSH. SSH is a little bit more complicated. HTTPS is ideal for our Amazon Linux 2 machine. And what we're going to do is edit the .getConfig file so that our IAM user is recognized in this whole communication. And remember, the IAM user already has appropriate permissions to code commit. Now, to set up our HTTPS credential helper, there's some prerequisites which we've already done. We created our IAM user, we attached the code commit policy to this user, and we've set up Git, and of course we have our AWS CLI configured already. So we're ready to go. We're ready to configure our HTTPS credential helper. Now, it doesn't hurt to double check to make sure our AWS CLI is configured. I'll just do AWS help. There's our help. We're good to go. All right, so let's configure our credential helper, and we're going to use a git command. Git config global credential helper AWS profile code commit configure code commit credential helper $, and I'll explain this momentarily. All right, so our command is git config, and we have -- global. This could be local. And what this means is, because it's global, we're assigning this configuration to all of the code commit repositories in our account. So this is actually a pretty powerful command. Now, if we had local, we could have different repositories with different profiles. So there's a lot of flexibility here. Now, our string inside of these single quotes is the string we're going to put in our .gitconfig file. And what that's doing is pointing Git to our AWS credentials. So let's run that. And with the CLI, no news is generally good news. Now we need to run this second command. All this is doing is indicating that we're using HTTP rather than SSH. Let's go ahead and run that. And then finally, let's run git config global edit. And this will be self-evident when we run this, but we got an error. And a lot of times these errors can be great learning tools. So what do we think the problem is here? Well, the problem is we're working with Git commands, but we haven't created a Git repository or cloned one. And this command is looking for just that. It's looking for a repository. So let's go ahead and do git init. All right, initialized empty Git repository, and that's fine. And notice, so now let's run our git config global edit. And there's our config file. And you see the command that we submitted to this file. So we're all set up. We are ready from our server and from a user perspective to communicate with code commit. So to recap, we configured our EC2 instance. We installed Git on our Amazon Linux 2 machine. We configured IAM for our user to communicate with code commit. We attached that code commit policy to our user. And finally, we set up our HTTP credentials to communicate with code commit. Now the next steps are to create a code commit repository and clone that repository. But we'll save that for an upcoming lesson. So thank you for joining me in this lesson, and I will see you in the next lesson. Hey folks, welcome back. So in this lesson, we're going to focus on our IAM configuration. Now, to be very clear, we already set up an IAM user in the previous lesson, and we gave that user code commit privileges. And if you want to follow along with that user, that will be perfectly fine. So this lesson is actually optional. But if you want to follow along exactly as I'm proceeding through these lessons with the exact names of the users and their permissions, then you can go ahead and configure the users as I will do in this lesson. One additional thing we'll do in this lesson is create an IAM group and put our users into that group. We attach a policy to that group, therefore giving all of our users the permissions of that policy. So it's just a little bit of extra IAM learning in this lesson. Again, it's optional, but if you want to follow along exactly, please proceed with this lesson. We want to protect our repositories, and we do that in AWS. We need to set some things up in IAM. We want to go over to IAM. And let's go to users, and of course we have our cloud user here. So what we're going to do, we're going to create an IAM user for code commit. And by that, we mean we're going to create a user and we're going to attach a code commit policy to this new user. It's going to assign the proper permissions to work with code commit. We're also going to create and retrieve access keys for the code commit user. And you'll see it's going to be very straightforward. So let's go ahead and add a user. And remember our development team, Erica, Paulo, and Yoshi. Let's go with Erica. Nice thing we can do is we can create these all at once. So let's add Paulo and add Yoshi as well. All right, and then we have our AWS access types. Programmatic access. So this is for when you want to access via the API, CLI, or SDK. We're certainly going to do that. And then the other type of access is through the management console. So let's just go ahead and do that as well. And notice when we clicked that, we can auto-generate a password or we can create a custom password. Let's just do a custom, name it what we want, but just remember to jot that down. Also remember it's going to be the same here. And this is cut off just a little bit, but let's go to permissions. Now, one of the things we can do is create a group for these users. Let's just go ahead and do that. But the advantage of in this way, we can attach one policy to our group, and then all users in our group will have this policy. The additional advantage is that as users are added to the group, they'll have these permissions. If they leave the group, then of course they'll lose those permissions. Let's give our group a name. We want to attach a code commit policy. We've created a group, which is going to make it a little bit easier for us. Let's go ahead and attach a policy. Typing in code commit, there's code commit read only, code commit power user. For our development team, let's just go full access. And that is going to allow them to interact with code commit, and they're going to have full permissions on code commit. We could add a tag, but I'm just going to go through this. There's our policy. AWS code commit full access. Create users. So that's a great start. We've given our development team full access to code commit. Just an important note here. So we have our security credentials, access key and secret access key. Notice that it says this is the last time these credentials will be available to download. Now, that sounds pretty ominous. And yeah, we should certainly handle these with care. But if we lost them or whatever, notice you can create new credentials at any time. So let's go ahead and maybe just copy and paste these locally somewhere. For now, we're in good shape. We created our IAM user. We actually created all of our users and additionally placed those users in a group. And that's pretty handy just to manage those users as a group. We attached the code commit policy to that group, and we created and retrieved our access keys for the code commit users. So with that, I'm going to end this lesson. Thank you for joining me. I will see you in the next lesson. Hey folks, welcome. So in upcoming lessons, to make for more realistic demonstrations, we're going to work from the command line as individual users. So when we SSH into our EC2 instance, we're going to SSH in as some of our users. And to do so, what we need to do is add those users to our EC2 instance. So we SSH into the EC2 instance as the general user, that EC2-user, and then we can configure other users in the EC2 instance and set them up so that they can SSH into our server. So let's go ahead and do just that. I want to make sure that I'm in my downloads directory. I'm going to SSH into our EC2 instance, but before that, we want to grab the public key of our key pair. Now, we could set up a key pair for each individual user, or we could use this key pair for all of our users. Either way is valid. So we'll just keep it simple and use the key pair that we already have. So what I want to do to get that public key is SSH keygen -y-f, f being the file. This is the key pair that we created when we created our EC2 instance. So whatever you named your key pair, that's what would be here. So let's go ahead and run that. And there it is. So we want to copy this and maybe save it to a Word document. And just make sure that you get all of it. Again, save that off to a Word document. We will need that later. Next, we just SSH in as our general EC2 user. This is given to us. We have to create other users. This one's given to us. So let's do that. All right. First thing we want to do is add our user. And I'll just point out that creating users in the management console is perfectly fine, but if you want those users to be able to SSH into your EC2 instance, you have to go through this process. So we add a user, and then we're going to switch our context to that user. Sudo su-jared, just note the spaces, and watch our context over here. And notice that we changed over to Jared. Now we want to make an SSH directory. mkdir space .ssh. After giving our user read, write, execute permissions to this directory, let's cd into that directory. Now what we want to do next is create an authorized key file. And to be clear, that's actually plural, authorized keys. Now we want to change the permissions on this file. And again, with the zeros, leading number up front, we're only giving permission to our user, read permission and write permission, because next we're going to vim into our authorized keys file. And you probably can guess what's coming here. We need to paste in our public key, which we retrieved from our keygen command. And then we can escape, :wq bang to exit. And that's it. We have set up a new user on our EC2 instance, and this user will be able to SSH into the instance. So let's exit out. Notice the first exit, just exit out of Jared. We need to exit out again, completely out of our EC2 instance. All right, so we're back to our own machine, in my case, my MacBook Pro. Just double check. I'm already in the downloads directory. So now I can SSH in as Jared. SSH -I. There's my key pair in double quotes. Here is my DNS for that instance, and I just need to change the username and just make sure that you get all of it. So now we can SSH in as Jared. So as many users as you need, you would go through this process. In an upcoming lesson, we'll be using 2 users. So if you want to follow along, just make sure that you've added 2 users to the instance, just like this. There we go. We are SSH'd into our EC2 instance as Jared. So that is the short process for adding users to your EC2 instance. Just be careful. Just make sure you get all of these commands in order. Otherwise, most likely you will get a permission denied. So with that, I will end this lesson. Thank you for joining me. I will see you in the next lesson. Hey folks, welcome back. So in this lesson, we're going to take a high-level look at code commit, but as we go deeper and deeper in the next lessons, we'll have a very solid handle on code commit. So our high-level goals for this lesson are to understand what code commit is and the benefits of using it. We'll also talk a bit about the pricing of code commit, and we'll get a high-level understanding of using code commit using clones and pushes and pulls. And after all that, we'll go to the whiteboard and check out a real-world scenario. So in previous lessons, we took a look at Git and GitHub, but just remember that code commit is AWS's version of this, a managed version. So at a high level, code commit is a managed source code control repository that hosts private Git, there's that word, repositories. And again, it's managed by AWS, much like RDS databases. So what are the benefits? Well, it's highly available, scalable, and fault tolerant. There's no size limit. And it integrates with other AWS services like Code Pipeline and Code Deploy, Code Build, Lambda, and SNS. And it works with existing Git-based tools. So really, it's a communication tools that allows the developers to collaborate on a project and easily manage, share, update, and coordinate code that they're independently working on. We'll see this in action, sort of an interactive diagram. All right, so before we get into the interactive demo, let's check out pricing. So basically, anyone with an AWS account can get started with Code Commit for free. Now, there is a cost when you reach certain limits. So your account gets 5 active users per month for free within limits, after which you pay $1 per additional active user per month. And there are no upfront fees or commitments. The first 5 active users receive unlimited repositories, 50 gig month of storage, 10,000 Git requests per month. And then there are additional charge if you run over this. All right, so let's take a look at our interactive demo. And let's say that we create a central repository. And we can do this in the management console. So let's actually do that. I'll just call it DevOps Pro Repo. And let's go ahead and create. All right, and notice that we have these 2 communication options we've talked about before, HTTPS and SSH, and we've already decided upon HTTPS. So for the purposes of the demonstration, we created our repository, and we have code in this repository. Although it's empty right now, I'll just talk as if we have code in this repository. And then we have our developers. And we'll go with Paulo and Erica, and they're working on their local machines. So how do our developers start working with our code commit repository? So let's just say Erica comes in on a Monday morning and wants to start working with this new repository. So what Erica can do is clone the central repository. And that's going to bring the latest version down of the main repository to her local machine. And she can begin working and realize that this is a local copy. So she's not bothering the main copy. So let's say Erica's task is a feature change. Well, she can work on that independently. And when she has completed and tested, then she can commit that feature. So the code has changed. And on Erica's local machine, this is key, on her local machine is a version 2. We just don't want to dump this back into the main repository. So it's still on her local machine. We're going to do some testing on this. But let's say that this version with the new features is ready to go. So what we then do is a push. Now notice, keep an eye on the version number. When we do the push, voila, we have version 2. And that's fantastic. Erica has developed a new feature. It has been tested, and we've pushed it to our main repository. Now think ahead. What's the problem? What's the next step? The rest of our team, whether it's just Paulo or whether there are 10 or 15 more developers, ultimately, they need to get this new version down to their local repository. That's where the pool comes into play. So maybe Erica slacks the team about this update, or we might have some automated SNS going on to inform our team of an update. Our team members can just do a pull, keep an eye on our version number. There we go. Now everybody is up to date with the new feature developed by Erica, version 2. And we could have automation triggered by the commit of new changes. So we'll see as we go throughout additional lessons how this can be automated. So we could be talking about CloudWatch events, SNS. We can do things with Lambda, but we certainly can automate this process. Now, again, if you think about this, there could be a situation where Erica and Paulo are working on the same file, possibly even the same lines of code. That can be an issue, but there's a way around it. We'll talk about merging in an upcoming lesson. All right, so to wrap this up, let's go to the whiteboard on this. So let's say that we're working in a small company. And let's say we have 3 projects and we're keeping a repo for each of those projects. We're storing each of those in their own S3 bucket. But our company is growing rapidly. We're worried about code conflicts and we're worried about losing work. Well, certainly see where this is going. We can go into the management console or we can do it from the CLI, but we can create some code commit repositories. We can migrate our code to these repositories. And we went from 1 developer to 5 developers. So of course, looking back at our diagram over here, developers are going to have to clone these repositories down to their local machine. And I'll just call it a Mac. And then I'm just going to work with this top repo and we'll have a production environment. But what if we want to do some testing? No problem. What about features? So our developer gets an assignment, adds a new feature, does a commit, can push that back out. And of course, we can send this code to test and eventually prod. But looking back from the start, it would be pretty simple to go from these S3 repos to our code commit repositories. And remember, those repositories are managed by AWS. We get all those features and benefits, but now we have a process here. So with that, I'm going to end this lesson. We took a look at the process of cloning a repository, committing and merging, pushes and pulls. And on the whiteboard, we just looked at an overview of how relatively easy it would be to migrate from S3 to code commit. And with that, I'll end this lesson. Thank you for joining me. I will see you in the next lesson. Hey folks, welcome back. So in this lesson, we're going to take a look at some of the main actions we can perform on our repository. And those actions include, of course, creating a repository, viewing a repository, or viewing multiple repositories by using the list repositories command, and then deleting repositories. So this will be a short but powerful lesson. We'll take a look at what we can do from the command line interface, but also see some of these actions from the management console and use the management console just to verify our work. And we're going to use the EC2 instance that we prepared in the previous lesson. We'll just SSH into that server and start working from the command line. And we have our SSH connection string, and I have the management console open over here. I'm going to just go over to EC2. We should know this, but just in case, we can go to our server and click on connect, and there's our connection string. So let's go ahead and do that. All right, now I'm just going to skip updates. I did updates last time. So we are ready to get rolling here. So first, let's just get a lay of the land, and we will list our repositories. So it's an AWS code commit command. And the command is AWS code commit list repositories. And of course, this is going to list all of the repositories that we have in our region. And we'll verify that in the management console. Got an error. This may or may not be intentional on my part. The security token included in the request is invalid. And you can probably tell by my voice that this was intentional. Learning from our mistakes seems to stick with us. So what I did was I intentionally deleted my access key and my secret access key. And that's always a good policy anyway. Just delete them when you're done using them. And then the next time you use them, just like I'm going to do right now, go over to IAM and go ahead and create a new set. And then when I'm done, I'll just delete them again. So I'll create my new access keys. And then over in the CLI, what are we doing here? Think about this for a second. We're doing AWS configure. plug in our access key, plug in the secret access key, and again, I'm showing these in broad daylight, but I'm unconcerned because the second I'm done with this lesson, I'm deleting these access keys anyway. Go ahead and hit return. Default region, that is the region I'm using. Output format, the default is JSON, that's fine. All right, so we should be good to go now. So let's list our repositories. AWS code commit, list repositories. There we go. Again, JSON output format, and I'm showing 5 repositories. There's a repository we created in a previous lesson, and then these are some other repositories, just some extras in our little movie here. Okay, so we listed our repositories, and of course we identified the important one here. All right, now from the command line, we want a little bit more information on our DevOps Pro repo. So our command is AWS code commit get repository. Then we provide the repository name, and that's it. There's our command. All right, so there's a bit more information. There's our repository name. Of particular note, check out our clone URLs. There's one for SSH and one for HTTP. And you'll notice they're exactly the same with the exception of specifying our protocol, SSH or HTTPS. We got a creation date. Here is our repo ARN and the account from which this repo was created. And speaking of created, let's go ahead and create a repo. But before we do that, let's bounce over to code commit and just verify what we've done so far. So our list repo showed 5 repositories, and that's exactly what we have. Notice the ordering. Management console is showing most recent to least recent, and the CLI is showing the inverse of that. But let's go ahead and create a repository. So our command is AWS code commit, create repository, and then again, we just provide the repository name. And I'm going to name it appropriately. AWS code commit, create repository, repository name, crush DevOps cert. There we go. There's our repo. There's our clone URLs, ARN, account ID. Let's just go verify, and I'll just have to refresh the page. There we go. Crush DevOps cert. Love that name. We're predicting the future. All right, so let's delete a couple dummy repos. First of all, from the management console, notice I specified a repo, and there's my delete repository button active. So let's go ahead and do that. Are we sure? Absolutely. Gone. Let's do one from the command line. AWS code commit, delete repository, and of course repository name. And let's get rid of dummy3 repo. All right, then we can run it. There we go. We got a repository ID back, no error message. So I'm expecting this to go away. Just refresh and gone. All right, so in this lesson, we just want to work with some of the main repository commands, some of the main repository actions, create, view, list, and delete repositories, both from the CLI and the management console. And of course, you may be just working in the CLI, so these commands will certainly be very handy from the CLI, but also just about anything you can run from the CLI, you can script. So you might be on the CLI testing out your commands and then putting your script together, testing your script, and then performing some sort of automation. So let's look at repository actions. With that, I will end this lesson. I will see you in the next lesson. Hey folks, welcome back. So in this lesson, we're going to start using Git commands to work with our AWS code commit repositories. So we're going to begin cloning repositories, doing commits, and pushes to the repository and pulls from the repository. And in doing this lesson, we'll also verify that everything we've done previous in our setup has worked properly, setting up our EC2 instance, setting up Git, setting up our users, and probably most importantly, setting them up to be able to SSH into our EC2 instance. Now, before we get started, I've popped out to code commit in the management console. And as we go through these next sections, code commit, code build, code deploy, code pipeline, we'll be working with some repositories that have a pizza-based theme, because who doesn't like pizza? So we'll be working with Cold Pizza Repo and also a repository named Pizza Demo Repo. So I'm just going to go ahead and create that right now. And again, just to be clear, if you want to follow along exactly with the exact names of users and repositories, then of course, create those users as we have done previously, create the repositories with the exact names. But really, these techniques we are using, of course, apply to any users, any repositories. Nothing particularly special about these repositories. They start out empty. So with that said, I'll just go ahead and create this repository, and we'll go back to our lesson on clones, commits, pushes, and pulls. So let's take a look at our diagram, and initially, we're going to need to clone the main repository. We'll do that with both Paulo and Erica. And then Paulo has some work he wants to do locally. We'll be able to see a commit and then push that commit to the central repository. Now that's great for Paulo, but Erica will then be out of sync with the central repository, but all she'll have to do is a pull from the central repository to get what we will call version 2. So these are really the core Git commands that we'll be using to work with our repository. And the first thing we are going to do is SSH into our EC2 instance, which is housing our repositories. And we'll first do that as Erica. So the command is SSH -I. There is our key pair, and we can now log in as Erica because of the SSH keygen process we went through previously. So let's do that. All right, so we are now logged in as Erica. I just cleared the screen because we're going to be doing a lot here. Now, the first thing we want to do is clone the main repository. So neither Erica or Paulo have the main repository yet. So cloning is going to clone that repository on their local machine. So Erica knows that she needs to clone, but what? What does she need to clone? Well, just in case she doesn't know, she can list the repositories as we've seen previously. AWS code commit, list repositories. What repository does she want? And the repository she's going to work with is this pizza demo repo. So Erica wants to do a git clone command, and of course that's going to replicate that central repository to her local machine. It's also going to verify credentials and set up that handshaking that's going to go on between the central repository and Erica's local repository as she issues more commands. All right, so we are working with HTTPS, and what do you think we need for this command? We need that HTTP URL for our central repository. Now, we could get this from the command line using the command AWS code commit get-repository and then just specify the repository name. Let's just cheat a little bit here. And here's our repository. Here's our clone URL, clone HTTPS. And we're going to be working a ton from the CLI, so I just want to show some of the capabilities in the management console as well. So let's copy that to our clipboard. So our command becomes git clone, our HTTPS URL for our repo, paste that in. And then just a space, and what Erica needs to do is give her local version of this repo a name. And she'll call it local pizza demo repo. This could be anything you choose. So let's run that, and it's cloning that main repository to Erica's local. How do we know? Let's do an ls. There's our new repo. Just clear the screen. All right, so Erica has cloned the repo. Meanwhile, Paulo has some work to do. So I'm going to exit out of Erica's account, and we need to SSH in as Paulo. There's our command. Paulo has some work to do, but he doesn't have the repository. So he needs to clone that. So let's run that command for Paulo. Remember, it's the same repository. Paulo just calls it local pizza repo. Doesn't take long. It's not a big repo. There it goes. All done. Let's just check. There we go. All right, so Paulo has some work to do, and initially he just wants to create a README file for this repo. So he creates a file with the touch command. All right, Paulo has a little bit of a sense of humor. I emphasize little. Just testing this file out. And then he can quit and save with a : WQ bang. And then the chmod 755 will make that executable, and then he can just test it. There we go. A little bit of DIY knowledge about broken pizzas. So now he wants to do a commit, and it's simply git commit -m, and then you can add a comment. A couple other commands go with that. One of those commands is git status, and this is telling us that we have an untracked file. This file's just kind of hanging Paulo's local machine, but we can add this to our commit with git add. So let's do that. Okay, and just to be clear, it added that file to Paulo's local commit. This hasn't gone anywhere yet. This hasn't gone to the central repository. That's where the git commit comes into play. What we can do is we can just keep adding new files that we create to our commit locally. Now, we could also be working with our testers and maybe have somebody test that for us before we push to the central repository. Let's git status again. Notice that it's changed a little bit from untracked files. Well, this file is essentially tracked now. We added it to our commit and changes to be committed. Now, what if Paulo made a mistake here? Let's say he wants to remove this file from his commit. So he would do git rm with an option of cache readme. Let's take a look at git status again, and we are back to this readme being untracked. I'm going to clear the screen. That rm is not deleting that file, it's simply removing it from that commit. But let's say Paulo really wants to add that to his commit, so we'll just put it back with git add. All right, so Paulo just wanted that one file. He's ready to commit, although that's not what his girlfriends say, but in this instance, it's true. So it's git commit, and then just add a comment for it. Paulo needs to provide a little bit more information. So that commit is not finalized yet. Git wants us to run these commands. Doesn't know who Paulo is. There's one with his email, and there's two. So let's try that again. The commit. There we go. So our commit is finalized. Understand though, this is still on Paulo's local repository. It is not yet to the main repository. This main repository is still at version 1, while version 2 is sitting on Paulo's machine. Now you probably can guess what needs to happen next. Paulo needs to do a push. Git push, remote name, branch name. We'll talk about that momentarily. All right, so let's talk about these commands. So with our git push, we need a remote name and a branch name, and these are repositories. Probably makes good sense. Let's do a git remote, and that is origin. That is where the commit is coming from. That's where we're pushing from. What about git branch? Master. That is where we're pushing to. So the remote name is the nickname the local repo uses for the central repository, origin. And then the name of the branch is the branch that you want to push to. We want to push to the master. What is git diff stat? Well, let's check it out. So we do git diff stat origin/master. And that essentially is telling us what we're pushing. And of course, we only have one file to push. So we're ready to push. Let's go ahead and do it. And it is git push origin, note a space rather than the slash master. So we are pushing Paulo's commit to the central repository. Let's do it. There we go. So our push has completed. Now, let's just go use the console, and we should have a README file here. So let's just refresh. There it is, with a little bonus learning here. Let's go back. So Paulo did a clone. He then did some work locally, created a commit, pushed it to the central repository. So Paulo's on version 2, and our main repository is also on version 2. So what has to happen next here? Well, remember, Erica had cloned the repository, but she has version 1. She needs to get version 2 at some point, and she'll do that with a pull. Pretty much the same syntax as our push. And of course, she can learn these names of the remote using git remote and git branch. And of course, it's going to be the same. Remote will be origin, branch will be master. So let's exit out of Paulo's login. I'll clear the screen. We want to SSH in as Erica. So let's just get our bearings here and do an ls, and then we'll change directories into the original repository that Erica cloned. Now remember, Erica is still at version 1. She does not yet have the update, and that can be verified just with an ls. There will be no README file there. So of course, Erica wants to do this pull. And that's going to pull everything from the central repository since Erica's last sync. And of course, her last sync was that clone of version 1. So she needs version 2, and essentially that is just the README file. Now we know what's going to come up here, but let's do it anyway. Let's do a git remote origin, and git branch will give us master. So the pull command is simply git pull origin space master. All right, that pull pulled our one file down to Erica's local repository. She's now on version 2. Everybody is in sync. Erica prefers Backstreet Boys, but she is now in sync. And remember, here's our all-important HTTPS URL where to pull from the master. This is good. We know it worked. We can just do an ls, and we will see our README file has been added in Erica's local repo. Now, the question is it executable? Well, let's find out without doing the chmod. The answer is yes. So that file was pulled down and retained the permissions that Paulo assigned to it. So everyone's in sync. Everyone is on version 2. Paulo, Erica, and our central repo all on version 2. And really, these are the core commands to work with our code commit repository. We cloned, did some work locally, and did a commit. Remember, the commit remains local until we do a push, and then our other developers, in this case, just Erica, needs to get up to date at some point by doing a pull. So those are the core commands. If you really understand this lesson, you'll go a long way in understanding how to work with code commit. Now, complications arise. We'll talk about that in our next lesson. So please join me in the next lesson. Hey folks, welcome back. So in this lesson, we're going to talk about conflict resolution. All right, so how are conflicts introduced? Well, if we recall from the last lesson, everybody was on version 2. Paulo created a README file, committed and pushed to central, and then Erica did a pull, and everybody's on the same page. Let's say that Erica edits the README file. Meanwhile, Paulo is editing the README file as well. And what happens if they're editing the same lines of code? Well, there's going to be a conflict, and it's unlikely that the changes they make are going to be exactly the same. So whose changes do we accept? So that's how conflicts are introduced, and we'll see how we have to resolve these conflicts. All right, so as you'll see, I am SSH'd into our EC2 instance as Erica. So go ahead and do that if you're following along, and revisit that process in previous lessons if you need to. And as Erica, let's make edits. So I'm going to cd into our repo, ls, there is our README. And remember, we only have one line, so any edits is going to cause a conflict. Now, of course, if there were 200 lines of code, there's a good chance that there would be no conflict. Of course, unless, as in this instance, Eric and Paulo are working on the same line of code. So with Vim, let's edit our file. And I'm just keeping it simple, but it will serve the purpose that we need it to. Then I'll hit escape, :WQ bang to save. All right, so now let's do the same as Paulo. All right, and as Paulo, let's go into our repo, edit our file, and save. :WQ bang. All right, so we have a potential conflict here. So as Paulo, let's add our changes to a commit. So we do git add readme. So Paulo, click on our orange star, wants to do a commit, and that will create a version 3. So let's go ahead and do that commit. All right. And just remember, we did the commit, but this is still on Paulo's local machine. How do we get it to our main repository? With the push. There we go. Let's go over to code commit in the management console. Note our repo last modified just now. Well, that's encouraging. There we go. All right. Now let's do our commit as Erica. Back SSH'd in as Erica. First thing she needs to do is add her changes to a commit. Git add readme. So clicking on our orange star for commit. Now we're a step ahead here on the diagram. Let's go ahead and finalize our commit. And of course, we have to push to our main repository. Lots of dialogue here. That's not promising, but of course we know what the problem is. Sifting through this is instructive. You may want to first integrate the remote changes, usually caused by another repository pushing to the same reference. Well, of course we know what's going on. We have a conflict. And this is kind of verbose, but it's telling us there's a conflict in a roundabout manner. We have a bunch of hints, but ultimately it's telling us, hey, there's an error. Failed to push. And again, we know what the problem is. We have a conflict. And maybe the most important hint is telling us to try a git pull before pushing again. So let's do that. And remember our command, git pull origin master. Now we're really at the heart of the matter here. All capitals, conflict. We have a merge conflict in README. How do we fix this? All right, so let's go into some conflict resolution. Let's open up our README file. Oh, wow, this is cool. Code commit is showing us the conflict. Here's Erica's version, and it's showing Paulo's version. Really helpful. Now, of course, we know what the conflict is, but just think. Let's say that they were editing 2 JSON files or Python. This would be extremely helpful. Now, what's going on here is this is a head pointer, and this is referring to the most recent commit. And as we know, Erica's is the most recent commit. Then this is sort of a wall, and this is showing what is the latest accepted version on the main repository, which was Paulo's. Paulo pushed his commit, it was accepted. Erica pushed her commit, and there's a conflict. And that's what this is telling us. And this is a hexadecimal number This is the commit ID, and this number is specific to this commit, and it'll always be different for each commit. Now, this is the long form. What you will usually see is the first 7 digits. So when a commit is performed successfully in the response, you'll see the first 7 digits. So how do we resolve this conflict? Well, let's say that Erica slacks Paulo. Hey, Paulo, I have a conflict here on this line of code. So they have to work out which one of these lines of code do they want to use. Now, let's say they decide that they want to use Erica's line of code. So all Erica needs to do is edit this file and just remove everything she doesn't want. She's removing Paulo's edit, and she's removing the helpful information, the head pointer, and our wall here. So essentially telling code commit, hey, this is the direction we're going with this. So let's save, clear the screen. All right, so we just do our procedure again for commits. We add it back to our commit. We finalize the commit, and then we push it back to the master. Much different response here. Usually less is good with these responses, and looks like we had success, but trust but verify. Remember previously Paulo's edit. Let's refresh. Success. So we have successfully gone through our conflict resolution. We have merged this conflict and everybody's happy. Erica has the latest version. We know we pushed this to our main repository. What about Paulo? Let's go over to Paulo's machine. And of course, he still has that original commit that ultimately was overridden by Erica's due to our merging of conflicts. All Paulo has to do is a pull. One file changed. Note the first 7 digits of that commit ID. Clear the screen. And let's check out the README. Now this should be Erica's edit, and it is. So now everyone's on version 3. Our conflict has been rectified. Everyone's on the same page and ready to move forward. So to recap, just have to understand how the conflicts are introduced in the shared code repository, and more importantly, understand the steps we need to take to resolve these conflicts. So we have successfully merged conflicts in code commit. So with that, I will end this lesson. Thank you for joining me. I'll see you in the next lesson. Hey folks, welcome back. So in this lesson, we're going to talk about code commit branches. But before we do that, well, what is a branch and why do we need branches? So branches are an independent line of development. They allow us to safely make changes to code without disrupting the code on the master branch. So let's say that Paulo gets a new assignment. He's going to do some web development with some HTML, a little bit of Python. So what he will do is create a branch from the master. Now, he'll start out with an exact copy of the master. Just a very simple way to think about this is that the master is our production code and a branch is development code. If we need to fix a bug, we don't want to be mucking around on the master. We just create a branch. We have an exact copy of the master, but we have a bug that we need to fix. So we can do what we need on the branch, fix the bug, test our fix, and then merge back to the master. Likewise, let's say we have a new feature. Let's say Paulo has some web development to do, working with HTML and Python maybe. Same principle. We don't want to be doing this on our production environment. So we create a branch, develop the new feature on the branch, test that, and then merge back to the main repository. So that's what we're going to do in this lesson. Let's take a look at our recipe for success. We're going to learn how to create a branch. That's most important, but what do we do when we get that branch? Well, we'll also get into viewing a branch, switching between a branch or branches and our main repository, merging, and then ultimately, when we're completed work in our branch, in other words, we finished our bug fix or our new development, tested, merge back into main repository, well, then we can just delete that branch. and we'll see that in this lesson. So much to do. Let's get started. All right, so let's get back to Paulo, and Paulo has some work to do. Paulo needs to create an HTML file. So we're SSH'd into our EC2 instance as Paulo, and Paulo needs to create a branch for this new development. So when we create a branch, our command is git branch. This will create a new branch. We'll see that momentarily. A related command is git checkout. Now this creates a branch and switches into it. And here are some examples. All right, so let's touch base with Paulo. Again, SSH'd in as Paulo, and we are in our repo directory. Now we want to create this branch, but let's just create it and go into it as well. So we'll use the git checkout -b and keep an eye on where we end up. So we're creating a new branch, just calling it menu, and we want to go into that branch. So it's git checkout -b menu. Switch to a new branch named menu, exactly what we want. So Paulo wants to start with a landing page, which will ultimately be a menu. Let's go ahead and do that. All right, so we'll touch that HTML file, and then we can just vim to edit it. All right, and again, it's an HTML file, and the main message is menu coming soon. So Paulo is going to create an interactive menu ultimately. And as we know, Paulo has a little bit of a sense of humor. What does an aardvark like on its pizza? Anchovies. And it's a good thing Paulo has a day job. Let's save this. :WQ bang. There we go. All right, so we have a branch with some code in our branch. How do we navigate between branches? Let's just do a git branch. So this lists all of our branches. We have the master, and then it lists with the star and the green, the branch that we're currently in, our new menu branch. Let's try another branch command. Git branch -r lists our remote branches. So this lists the branches in our main repository, and realize that our new branch is local to Paulo's machine as of now. So it is not listed here. Now, what about switching between branches? Well, locally, we only have two. We have master and we have menu. We're in menu. Let's switch to master. We do that with git checkout master, and it spells it out for us. Switch to branch master. Your branch is up to date with origin master. Well, it's up to date. We haven't really done anything other than create this file in our branch. The master's unaware of this file right now. And let's just do a git branch. Notice that the star and the green writing is now on master, but it is listing our second branch, our menu branch. All right, but Paulo has work to do in the menu branch. So let's go back. Git checkout menu. All right, switch to the menu branch. Just for the heck of it, I'll run git branch. Notice our change. Do an ls. Here's our new file. So Paulo's happy with this file. What do? Well, let's add it to a commit. Git add superbmenu.html. Do you remember what's next? Git commit. All right, let's do our commit. Now, you might think that we would do a push at this point, but with the branch, it's a bit different. So what we have to do is switch to the master branch. So I'll do a git checkout master. All right, so we are in the master. Now what we do from the master is a git merge. Merge what? Merge our menu branch. Now this is assuming in the real world, this has been our menu branch and our new feature has been thoroughly tested. We're ready to pull it in to our master branch. And notice one file changed, our superb menu HTML. Clear the screen, do an ls. There it is. So we have successfully created a branch, added a new feature to that branch. Now we didn't test it, of course, but there should be some thorough testing before that branch is merged back into our main or central repository. So we no longer have use for our branch, our menu branch. We don't need it anymore. So we can just delete our menu branch. And we do that with this command, git branch -d menu. There we go. Remember our shortened commit ID? So that branch has been deleted. Verify that. Trust but verify. Menu branch is gone. So we have one more step to do, and just think about that for a second. But let's take a look here at our diagram. So we created our branch, added a new feature, and I'm going to click on our star here. And this will give you a hint of what needs to be done. Watch how the diagram changes. New feature, we merge that into the master. But remember, this is all taking place on Paulo's machine. So Paulo has version 4 with the new feature. So what do we have to do? We have to push this back to our main repository. So that is the next and final command. Git push origin master. There we go. So now Paulo has version 4 and main repository is up to version 4 as well. Eric is still on version 3. Let's go over to our console and refresh. Trust but verify. There's our new menu file. What does an aardvark like on its pizza? Anchovies. So we have successfully created our branch. We have updated our branch, committed our changes, pushed those back to the main repository. And with that, I will end this lesson. Thank you for joining me. I will see you in the next lesson. Hey folks, welcome back. So in this lesson, we're going to learn a bit about code commit triggers. And code commit has many advantages over other repositories, foremost being that it is an AWS managed service and AWS handles a lot of the behind the scenes work for you. But another great advantage is the use of triggers. It's a very powerful tool, and we'll see as we go through the next several lessons what triggers can do for us. Now in this introductory lesson, it's going to be brief. Just want to introduce the concept of triggers. We want to understand triggers and how they can be used with code commit and understand which AWS services can interact with code commit. And then in subsequent lessons, we'll start to integrate triggers with these other services. Now, if you know anything about AWS and maybe even a little bit about AWS Lambda, well, then you're a little bit familiar with triggers. Lambda functions need a trigger to be activated. And there are many ways that triggers can be triggered. Updating a DynamoDB table can trigger a Lambda function. Adding a file to an S3 bucket can trigger a Lambda function. And the great power of it is all you have to do is supply that trigger, and then the Lambda function could be any function under the sun that fits your use case. Now, the scope of code commit triggers may be a bit more narrow than that. In most cases, maybe we just want to trigger an SNS topic, but you'll see we can also trigger Lambda functions. And again, that Lambda function could be anything. So there's really a broad scope with this and great power to it. Now, I've sort of explained what are triggers, but let's look at it anyway. Triggers are methods where events in code commit, such as creating a branch, can launch actions in other AWS services. So example, say we create a new branch. This can trigger an SNS topic to notify all subscribers of the new branch. And the benefit of that is the subscribers can decide for themselves. Hey, do I need this new branch? And if so, well, I better go clone this new branch. Triggers can evoke actions in the following AWS services: SNS, Lambda, and once again, we provide the trigger from code commit. This Lambda function could be anything we need it to do. So there's really great power and flexibility with that. Now, the triggers can't work with SQS directly, but we could trigger an SNS topic, which can then work with SQS, simple queue service. So there's a lot of flexibility here, and it's a great feature. And again, this is another thing that separates code commit from other repositories. But really, in a nutshell, we can use triggers in code commit to affect actions outside of code commit. And that's really the best way to describe the power of this. Now let's look at the management console. So we have our repositories, and let's go into Erica's cold pizza repo. Where are triggers? Well, let's go into settings, and we'll save the great detail on this for the next section. But you can see here are triggers, and I'll just click create a trigger. Again, we'll complete this action in the next lesson. So we give our trigger a name. Now we talked about the services that our triggers can interact with, SNS and Lambda, and then SQS through SNS. But what about events? Which events can invoke triggers? So right off the top, any event that occurs in our repository could invoke a trigger. Or we can get more specific, a push to an existing branch. We talked about creating a branch, but also the creation of a tag could invoke a trigger. And likewise, deletion of either a branch or a tag. So again, just thinking of the most common scenario, let's say we have a large development team and they are subscribed to an SNS topic, and really we could have it so that any repository events trigger our SNS topic. Our whole team is notified of those events. Now this could turn into a bit of almost a spamming situation. Your team probably will get a little agitated with that, but again, we can narrow our focus as needed. So looking at our diagram, let's say that we want to create a trigger for the creation of a new branch. So we create the new branch, and that invokes our trigger. SNS is made aware of this invocation of this action we took, and our whole team is notified. The creation of a new branch. And they can decide immediately and individually, hey, I need that branch. I'll go ahead and clone that branch. Or, no, I don't need it. I'll just keep working, going about my business in my local repo. So that's an introductory look at code commit triggers. Now, in the upcoming lessons, we'll take a look at triggers for SNS, also for Lambda functions. So this is a really cool topic. Please join me in the upcoming lessons. Welcome back. In the previous lesson, we did an introduction to code commit triggers. So let's just dive right into code commit triggers for SNS. And just if it's not clear, SNS, Simple Notification Service, allows us to configure topics and send notifications to subscribers of that topic. And again, we can trigger all of this from code commit. We're going to create triggers for SNS from the console. So we just want to come out of this lesson with a good knowledge of how to create triggers. Now, when creating triggers for SNS, there are just a couple prerequisites. First of all, we must have an existing SNS topic. So one of the first things we're going to do momentarily is create an SNS topic. And then the other prerequisite is the repository, and the SNS topic must be in the same region. So first thing we're going to do, we'll just create a new repository for this walkthrough. And we'll just give it a name and a description and create. And then I'll just go back to repositories, and of course we'll see it at the top of our list. Now, I'm going to open up another tab, and remember, we have to have an existing SNS topic. So let's go over to SNS. Let's go into topics, and let's create a topic. And we'll just accept the defaults. There's a lot of optional things we can do here, but let's just create the topic. Now remember, we want to receive notifications from this topic. So we have to create a subscription, and we select the protocol. A lot of different ways we can receive notification. Let's just go with email, and I'll just enter my email address and create the subscription. All right, I'm going to open another tab and go over to my email. All right, so we got a notification. Now I have to confirm this. This is very important. I have to click this or I will not receive additional notifications. Confirm subscription. There we go. All right, so let's go back to code commit. Let's go into our new repo. Remember, for triggers, we'll go into settings, go over to triggers, And of course, we want to create a trigger, and I'll just call it demo trigger. All right, and we talked about these events that will invoke our trigger. So let's just do one for create branch. This will narrow the scope. We won't be spamming our team. And notice this is a bit strange. It doesn't populate in here. That's just a search. But if we close this, there it is. If you do not choose any branches, this trigger will apply to all branches in the repository. Let's just keep that. Of course, we want to do SNS. Then we select an SNS topic. Remember, we have to have created that already. There it is. And note that it populates the ARN of that topic. That's pretty handy. Now, the nice thing we can do is note this test trigger. We can test it right now. So that would save us some troubleshooting down the road if there was an issue. So let's click that, and we should have a message. So I go over to my email. There it is. All right. So our trigger is configured properly. So let's just create it. Okay. Now we're going to do some work from the CLI. All right. So SSH'd into our machine as Eric. So let's clone this new repository. And remember, we can just get that clone URL. Here's our repo. Here is our HTTPS URL. And remember, we just need a local folder to put that into. That's our command. We get a warning about the repo being empty. That's fine. What we can do is cd into our new folder, touch a file, add it to a commit, do a commit, and then, of course, just push that. I'll just clear the screen. Now, we can use git checkout to create a new branch. Realize what's going on here. So we're doing this now at the main branch. Simply creating a branch in a local repository does not invoke the trigger. The trigger will be invoked when the change happens in the main repository. So let's create a new file here. Add it. Finalize our commit, and then do our push. So at this point, we have essentially created two branches, branch at the master and this trigger branch. And what that means is we should have a couple email notifications. So I'm going to go over to my email. There we go, 2. And that is just about right. First one 4 minutes ago, and then 1 minute ago. Note, first time when we did that first push, master. And then this last time, there's our trigger branch. So our SNS notification is working properly. So looking at our code, just to make sure we're clear here, this git push origin trigger branch, we pushed our commit with this new branch. This action right here invoked our trigger, causing our SNS notification. Now I cleared the screen, but a few minutes ago we did git push origin master, invoke our trigger, which is tied to our SNS notification. This first email is the result of that first git push. So let's go back to our diagram, learn about code commit triggers for SNS, and create triggers for SNS from the AWS console and the CLI. So with that, I'm going to end this lesson. Thank you for joining me. I will see you in the next lesson. Hey folks, welcome back. So we've been learning about triggers for code commit, and in this lesson, we're going to learn about a really powerful functionality, triggers for Lambda functions. And coincidentally, Lambda functions need a trigger to be invoked anyway. So the concepts go hand in hand. Lambda functions just need a trigger. That Lambda function could be anything under the sun that you can write, be it Python or Java or any of the other supported languages. So we just trigger our function. It can be anything, and that is a broad scope and makes this a very powerful functionality. Now, when talking about setting up these triggers for Lambda with code commit, there are multiple ways that we can do this. One thing we can do is manually configure permissions to allow code commit to run a Lambda function. This would be done from the CLI. Now, we're doing a lot of work from the CLI, but we want to work smarter, not harder. And the easiest way to create a trigger that invokes a Lambda function is to create that trigger in the Lambda console. And by doing it this way, you can ensure that code commit has the permissions required to run the function rather than doing it manually from the code commit from the CLI, maybe running into some problems. Let's just work smarter on this one. Now, this isn't a course on Lambda, so we're going to have a Lambda function. It's just going to be a very simple random number generator. So we'll go over and we'll create our trigger for that. We have a Lambda deep dive, which I highly recommend if you have further interest in Lambda. Let's set up a Lambda function with a code commit trigger and we'll test it out. So let's go over to Lambda. We're going to use a random number generator function, but just a little bit of additional information. If we wanted to create one from scratch, we can author one from scratch. We can use a blueprint. Then we would go ahead and configure it, give it a name, an execution role, and ultimately create our function. But again, we'll just use one that's already created. Check out the Lambda deep dive if you want to learn more about Lambda. So I'm going to select this Lambda function. Notice down here we have the ability to add a trigger. Let's do that. Let's just click on the drop down. Notice the power of this. How many services can trigger a Lambda function? Of course, we want code commit. And notice it's already linking to our code commit repos. There are all of our repos. Let's just go with cold pizza repo. Give our trigger a name. And let's trigger on creation of a branch. And remember, this is a little bit tricky. We just click outside of this, and there we go. Now, we don't want all repository events, so let's delete that. Trigger will be configured for all repository branches and tags by default. That's fine. Custom data used to distinguish the trigger from other triggers that run for the same event. So we got multiple triggers, so we can just leave that. Let's add. All right, so we've set up our trigger. Now I'm going to open up another tab and go over to code commit. And remember, we created the trigger for our cold pizza repo. So let's click on that. Go to settings. Let's go to triggers. There's our new trigger. Now let's click on branches and let's create a branch. So I'll just call it cold pizza branch for Lambda. We're just doing it for this demo. Branch from the master, create branch. Let's go into our branch. And remember, we have created a trigger which is going to invoke our Lambda function simply whenever we create a branch. So we just created a branch. So let's go over to Lambda and verify. All right. So we have trigger was successfully added to the function. The function is now receiving events from the trigger, and lo and behold, our Lambda function has since executed. Again, it's just a random number generator. And remember, these functions can't execute themselves. They need to be invoked by a trigger. So something invoke this trigger, and of course we know our creation of a branch invoke this trigger. So we've successfully configured a trigger from code commit for a Lambda function, and we just tested it out. This thing is in good shape. Now, one thing I want to show, because I mentioned working smart, not hard, let's click on Designer. So here's our trigger, and it's highlighted in blue. And with that, when we click on View Permissions, here's a policy for our trigger. And of course, it's giving some permission to code commit. Here is our ARN. Scroll over, ARN code commit US East 1. There's the account number, cold pizza repo. So cold pizza repo has these permissions, and here's the execution role. Lambda functions need an execution role. So by setting up our trigger from the Lambda console, we just kind of avoided some what I'd call grunt work here. We'd have to have set this up from the CLI over in code commit. Just doing it in Lambda, this was all set up for us. And that's just kind of a trick of the trade. Just knowing the Lambda console a bit just saved us some work. So that's it. We've successfully triggered a Lambda function from code commit. And with that, I'll end this lesson. I'll see you in the next lesson. Hey folks, welcome back. So in this lesson, I just wanted to do a short lesson on encryption of data in code commit. It's something we should be aware of. In truth, if our account is set up properly and our users with the code commit policies we did earlier in the course, again, the encryption is handled by AWS and specifically AWS KMS Key Management Service. But it's good to be aware of it and understand what's going on. Code commit data is encrypted in transit and at rest. So when data is pushed into code commit, for example, by a git push, code commit encrypts the received data as it's stored in the repository. Now, when that data is pulled from a code commit repository, and the obvious thing here, by a git pull, code commit decrypts the data and sends it to the caller. Now, this is assuming proper IAM authentication has taken place. And of course, we know by now we're doing it. Data sent or received is transmitted using HTTPS or SSH encrypted network protocols. So we have the at-rest encryption covered. We have the in-transit encryption covered. This is handled by AWS KMS, and there are some things going on that we may be unaware of. So the first time we create a code commit repository in an AWS region in our account, code commit creates an AWS managed key. Let's check this out. Let's go over to Key Management Service, and for whatever reason it went to customer managed keys. I don't have any of those. Let's go to AWS managed keys. Key phrase, AWS managed. I didn't have to do anything for these keys to have been created. See one for S3, SNS, Lightsail, EBS. There's our guy, AWS code commit, secrets manager, RDS, Lambda, Cloud9. Simply by working with these services, and I'll just get specific with code commit. The first time I created a repository in this region, in this account, happens to be roughly 7.5 months ago, this managed key was created for me. I didn't have to do a thing. And as you would expect, this key is used only by code commit. So this key does a lot of work for us. This encrypts and decrypts the data in our repo and in all of our repos within this region. Now, I do most of my work in US East 1, but let me bounce over to US East 2. And we see, notice there's a code commit key. It's not a duplicate key. This is by region. So this only works within US East 2, which happens to be Ohio. US East 1, this is the code commit key for this region. So it's fully managed. We don't have to do anything with it. We could be completely unaware of it. It goes on behind the scenes. It's good to know what's going on with the encryption. Looking at our diagram, SSH or HTTPS. So we have encryption in transit, KMS. We have encryption at rest. Couple key points. Let's go into this thing. Notice there's no radio button or delete button anywhere to delete this managed key. I cannot delete this thing. AWS managed. Now, customer managed keys serve a different purpose, and all we need to know is we cannot use a customer managed key to encrypt or decrypt data in code commit repository. So basically AWS is saying, hey, we have this, trust us. So just wanted to do a short lesson on this, and basically we just need to understand how this happens. We need to know and trust that our data is encrypted in transit and also at rest, and it is fully managed by AWS. So that's a look at how to protect our data and repositories from the outside world with encryption. But we also have to protect our repositories from in-house. Now, of course, the outside world could be more malicious, but in-house, we need to protect our repositories from accidents. And we talked a little bit about this in a whiteboarding session at the beginning of this code commit section, and we'll just go a little bit deeper on that now. So we'll go back to our scenario where we have prod, test, and feature branches, and we probably don't want just anybody doing commits to our prod branch. So what do? Well, we can create groups in IAM. So let's actually bounce over to the IAM console. We can create a new group. And I'm not going to go through all of these, but let's create an operator group. And then we can begin to attach policies to this group. And that will dictate what our groups can do in code commit. Now we've seen already the code commit full access. Let's describe these groups first. As you might expect, the admin pretty much has full permissions. They can manage our repositories, manage our branches, pull and push code. But that's it. That is the only group that we want pushing data to our prod branch. And one way we can do this is to create a policy which restricts that permission. We create the policy, I'll just call it no prod, and we can attach it to those groups that we don't want to give the ability to affect our prod environment. Now, such a policy could look something like this. So I'm out on the AWS Code Commit site, and we have effect deny, and look at the actions. Git push. So attaching this policy to our specified groups will disallow a push to our prod. Now this is calling it master, but they're synonymous in this instance. So our policy is denying all of these actions to our master repo or prod branch, however we want to do this. We just put in the appropriate reference. So all that we do is we create such a policy, or we can use existing code. There's code for this everywhere. And we go to IAM, and we can go into policies and create such a policy. Plug in our code, create and name the policy, and attach it, again, to the groups that we don't want affecting our prod code. So it's pretty straightforward. And again, the encryption that we talked about earlier in the lesson is protection from the outside world. But with IAM policies and groups, we can provide protection from in-house, not so much malicious, but accidental actions that could affect our prod environment. So that's a look at security and encryption for code commit. With that, I'm going to end this lesson. I will see you in the next lesson. Hey folks, welcome back. So in this section of the course, we're going to look at a new service in our AWS Developer Tools suite. We're going to look at Code Build. We're going to learn what Code Build is and how it is used in DevOps, learn from where and how Code Build can be run, and also learn about pricing for Code Build. So what is Code Build? It's a fully managed build service in the cloud. Fully managed, there's that key word again. And we saw how powerful that is in the last lesson, in the last section with the KMS service. Our keys were fully managed. We really didn't have to do anything. And in fact, we could have been completely unaware of that behind the scenes. So we're getting a lot of help from AWS here. But in layman's terms, Code Build is kind of an unsung hero. We're doing a lot of prep behind the scenes. But just think about what Code Build is doing. It compiles our source code. It can run unit tests and produce artifacts that are ready to deploy. Now, what are artifacts ready to deploy? I'll use Java as an example. An artifact from Java that is ready to deploy is a jar file. Just has a .jar extension. And no matter what kind of language we're working in, they will have similar such build files. Code Build eliminates the need to provision, manage, and scale your own build servers. And you might be thinking, well, what's this magic? I don't need build servers? Well, of course we do, but remember, Code Build is AWS managed. So it's one of those great services where we don't have to worry about any of that. And in fact, it's a very strong feature and a reason why we might choose Code Build. We don't want to have to worry about that. Good analogy I'll use is the use of Elastic Beanstalk. In a similar sense, if we're a small software shop, we don't want to deal with servers, provisioning, and all that stuff. Well, we could use Elastic Beanstalk. Deploy our code. AWS handles the rest. So back to Code Build, same deal. We don't have to worry about provisioning servers, managing them. let's focus on our code and getting it deployed quickly and ultimately with an eye on automation. Now, another nice thing about Code Build is that it provides prepackaged build environments for popular programming languages and build tools such as Apache Maven and also Gradle and several more. But we can also customize build environments in Code Build to use our own build tools. And Code Build scales automatically to meet peak build requests. Why does it scale automatically? AWS set it up that way. It's a managed service. We don't have to worry about its scaling. So it's fully managed. It scales on demand. And with that scaling, talking about billing here, we pay only for the number of build minutes that we consume. So it's going to scale as needed and scale back down when not in use. So we're not just racking up a charge with Code Build. It's just going to be used when needed and billed as such. So if we look at our diagram, and I'll just click on the benefits, we've talked about the benefits. We've certainly described it. What is Code Build? We've talked about that. But looking at our diagram, we can run Code Build, and hopping over to the Management Console, we can go into Code Build in the Management Console or the Code Pipeline Console. Now, additionally, we can automate the running of Code Build by using the CLI or SDK and just make calls to Code Build from our code. So again, Management Console, CLI, SDK, Code Pipeline. We can add Code Build as a build or test action to the build or test stage of a pipeline. And I realize we don't know a lot about Code Pipeline yet, but essentially it's a way we can automate our deployments. Code Pipeline can manage all of this. It's a continuous delivery service, and it's going to enable us to model, visualize, and ultimately automate the steps to release our code. And this includes our build phase. So when you think about a pipeline, just think of a workflow which is describing how our code goes through a release process. Now, we talked a little bit about pricing for Code Build. And again, it is a simple pay-as-you-go pricing. There are no upfront costs or minimum fees. You pay only for the resources you use. To be clear about that, I have a couple build projects here, but they're not sitting here accumulating charges for me. You're only charged for compute resources based on the duration it takes for you to build to execution. So only when we're performing a build is there a charge, and it's a per minute rate. And that rate depends on the selected compute type. So I'll break that down just to give you an idea of cost here. And let's say we execute 100 builds in a month. Let's say we're using a small size server and each build runs for 5 minutes. So I'm just going to pull up a AWS calculation on pricing. All right. Again, it's pay as you go, no upfront costs. Compute types. Code Build offers 3 compute instance types, different memory and CPU. Charges vary by the compute instance type. And here are charges per minute. So let's say we're doing builds with a general one small, I believe that is 5/100ths of a cent. So example, if you execute 100 builds in 1 month, general.small, each build runs for 5 minutes. Here's the calculation. 100 builds times 5 minutes equals 500 build minutes. Build minutes minus free tier build minutes, monthly billable build minutes comes out to 400. And then we multiply that by our 5/100ths of a cent. So our monthly charge is $2. So again, these costs are pretty minimal. Certainly if you're in a big shop, you'll be doing more builds, but again, it's pretty darn reasonable. Now, I'm not going to create a build project in this lesson, but let's just take a look. Project name and description. We could add some tags, specify our source, and notice our options: S3, GitHub, Bitbucket, GitHub Enterprise, and of course, code commit. Then we can specify our repository and notice the linkage to our code commit repositories. Environment image. Use an image managed by code build. We can pull Docker into this equation, specify our operating system, service role, build spec. We'll talk about build spec in an upcoming lesson. So just a general sneak preview at creating a build project. But this is just the introductory lesson. I'm going to end it right here, and we'll get much deeper into code build in the upcoming lesson. So please join me. Hey folks, welcome back. So we know a bit about code build. Now we're just going to go deeper on code build. We'll just walk through the steps in a typical code build project build, and then we'll just do a walkthrough of a build itself. We're going to learn a bit about a build spec file, which code build kind of uses as a blueprint. This lesson is just to get a good idea of the process. So looking at our diagram, we have numbers for our steps. In the first step, we need to provide code build with a build project, and a build project will define how code build runs a build. It's going to tell code build where to get the source, the build environment to use, the build commands to run, and where to store the build output. Step 2, code build uses the build project to create the build environment. Step 3, code build downloads the source code into the build environment and uses the build specification, build spec, and the build spec is a collection of build commands and related settings that code build uses to run a build. Now step 4, if there's any build output, the build environment uploads its output to an S3 bucket, but we could also specify some other tasks such as sending build notifications to an SNS topic. Step 5, while our build is running, the build environment will send information to code build as well as CloudWatch logs. So we'll have a record of what all happened during the build. And finally, also while the build is running, we can use the console, the CLI, SDK, or code pipeline to get summarized build information from code build. Now, in code pipeline, it's a bit more limited information than, for example, the CloudWatch logs. That is the process. Now, let's go ahead and just walk through this process with a sample build. All right, so I'm going to bring up the management console, and the first thing we want to do, let's go to S3, and I'm just going to call it code build input 92619. Today's date. Remember, these bucket names have to be unique. And I'll just next through and create the bucket. There it is. Then we need an output bucket. Same format, code build dash output 92619. Just next through and accept the defaults and create the bucket. All right. So there are our 2 required buckets. And a requirement is that these buckets need to be in the same region as our builds. And I'm working in US East 1. All right, so now let's SSH into our EC2 instance. Let's go over to our instance and connection information. Done this already, but I'll do a chmod, and then we can SSH in. What we need to do is create a folder structure with source src as the top level, and we want a main and a test folder underneath source. So I do that, make directory source, then I can cd into source. mkdir main and mkdir test. And I'll just do an ls to verify. Looks good. Now each of these folders needs a Java folder. So first I'll go into main, mkdir Java. I'll back out of there. Now I'll go into test and make a Java folder in test. Now I'll back out of test. And let's just get our bearings here. All right, so we're at the source level. Let's go back into main and then into Java. Again, I'll just check our bearings. Good. Now I'm going to clear the screen Now we need to create a messageutil.java file and then use Vim to edit that file. And paste in the messageutil.java code provided with the lesson. Then we can escape, WQ bang to save. Now we need to go over to the test folder and do something similar. So back out a couple times. Notice we're at the source level. That's where we want to be. Now we want to go into test and then the Java folder. And we're going to touch test messageutil.java and Vim to edit it. Press any key to enter insert mode and then copy in the test messageutil.java file provided. And basically it's just printing out some messages, but the main point of this is we want to build this code with the ultimate outcome being a Java jar file. That is the product of this. Now the Java jar file is the output from code build. If we took it a step further, the jar file could be the input to code deploy. And you see the makings of a pipeline here. So with this file created, let's escape, WQ bang to exit and save. All right, so I went back to the root level. All right, so I CD'd back. Actually, I went back too far. CD'd into home, CD'd into my EC2 user. I want to be at the same level as this source directory, basically the root level. And that's where we're going to introduce the pom.xml file. And we're going to use Apache Maven, and Apache Maven uses instructions in this file to convert messageutil.java and testutil.java into a jar file. So I want to Vim this file, just paste in the provided pom.xml, hit any key to enter the insert mode, paste in our file. Now I'm not going to get too deep into this. This isn't a Java class or a Maven class, but basically, again, this file provides instructions for our build. So let's escape, WQ bang to exit and save. Now at this same level, we need a build spec file. And build spec is a collection of commands and settings that actually runs the build. So we're going to touch buildspec.yaml and again, Vim into it. And paste in the provided build spec code. So we'll look at a build spec in more depth in the next lesson, but this lesson's more for the process. But basically, build spec is indicating what to install. There could be pre-build commands. We don't have any. And then the build. Just an echo. Here's the key one here. Maven install. Maven is doing our install. And then post-build, we're just echoing out a completion date. Artifacts. This is the output of this build, and it's going to be a jar file. And we'll see this artifact at the end when our build completes. So let's escape out, WQ bang. All right, next we need to zip up some of these files. Messageutil, testutil, pom, and our build spec. So the command is zip messageutil.zip. That's what we're naming the zip file. And then we start providing the files that we want to zip up. Buildspec.yaml, pom.xml. Now these files are at the level we're at, but we have to drill down to get to the other files. So we provide the path to messageutil.java. Likewise, the path to test messageutil.java. And there's our zip creation. I'm just going to clear the screen. Did an ls. There's our zip file. So that's still good. What we can do is copy this up to our S3 input folder. This guy. So the command is AWS S3 messageutil.zip. Where are we copying it to? This bucket. So it's S3 : / name of our bucket / the name of our file. All right, let's run that. All right, so I made an error. The error was I didn't provide the copy command. That's better. AWS S3 copy messageutil.zip. This is good. Unable to locate credentials. Now, we should know this by now. What do I need to do? I need to run AWS configure. And it's going to want access ID and secret access key. So let's go over to IAM and go in access keys. All right. Notice I don't have an access key right now. That's by design. Best practice is to not keep these access keys hanging around and just create them when you use them. When you're done with it, delete it. So that's what we'll do. And I'll just show these. It's not a great security breach because as soon as I'm done, I'm going to delete this. I'm going to delete these access keys anyway. So I'll paste this in. First, the access key and the secret access key. Default region, US East 1. All right. Now let's try our copy again. There we go. And we can verify this in the S3 console. Go into our bucket. There's our messageutil.zip. Now a key point for S3, our build spec is within this zip file. All right, now finally we need to create a build project. And we could do this from the CLI, but I don't want this lesson to get too long. Let's go to the management console for convenience and go over to code build. And it'll be good just to show a little bit of both CLI and management console. And we just create a build project. And I'll just name it code build demo with the date. Source provider. Defaults to code commit, but obviously we're using S3. And then we provide the bucket, and it is our code build input 92619. Object key, what do you think that is? messageutil.zip. Now we're going to use a managed image managed by code build. Just realize that Docker could come into play here. We could use a Docker image. Operating system Linux 2 and runtime standard image, this latest version. Service role, it's going to create a service role for us. Build spec, yeah, we're using a build spec file. It's in our zip file. Artifacts, S3, bucket name. Well, that is our output bucket. Code build output 92619. So our artifact from this whole build is going to be put here. And as you might have guessed by now, that's going to be a jar file. Now, if we wanted to create folders within our bucket, we could provide a folder name here, but we'll just keep it at the root level and we can skip the rest of this. Notice though that it's defaulting CloudWatch logs. So we're going to get some logs at CloudWatch, but we're going to see those logs on our code build monitor as well. And then we can just create the build project, our input bucket. There's our artifacts, our output bucket. That's where the jar is going. Let's go ahead and start this build. Now we're just going to accept the defaults on here. Just notice that the timeout for this operation is 1 hour and start our build. And we can just keep an eye on the progress and our logs are going to start to show here as well. All right. So our build succeeded. Now, here's our build logs, and there's a great deal of information here, and certainly I can't go through all of this, but certainly instructive to read through this. Ton of information, and just will show the progress of the build. Now, of course, if our build had failed, we'd search through here for error messages, but fortunately everything worked perfectly, and we have a successful build. And again, what we expect from this is ultimately a jar file, and we'll go verify that momentarily. So we had a success. Now, let's go over to S3 and verify our success. Go to our output folder. There's our code build demo 219 folder. Let's go into that. Target. There's our jar file, just created, just a few minutes ago. So that's the ultimate product of this build process. That's the output. Now again, this jar file could be the input to a code deploy operation, which of course we haven't looked at yet. But you can see the makings of a pipeline here. Input, output from code build, input to code deploy. And ultimately, all of this can be automated. So in this case, our pipeline is our repo, S3, and code build. And ultimately, code pipeline can oversee all of this. But this has been a look at code build and how to build our output artifacts, in this case a jar file, from our input artifacts stored in our repository. With that, I will end this lesson. Thank you for joining me. I will see you in the next lesson. Welcome back. So we've successfully done a build from the CLI, and now we're going to look a bit deeper into the build process. We'll take a look at our build spec file, talk about planning a build, and ultimately we'll do another build, this time from the management console. But really the heart of builds in code build is the build spec file. Now, if you look at my handy visual code editor, I have a skeleton of a build spec file up. And we'll talk about that. That's why I just named it build spec stub, because that's exactly what it is. It's a stub of a build spec file showing the key elements of this type of file. And we'll walk through and just get an idea of what we have in this file, understand it, and when we have to build one, then we're good. All right, so we have a version number and then run as. And as you would expect, the version number represents the build spec version, and 0.2 is recommended. There's a 0.1 that is still supported. Now, run as is optional, and it's available to Linux users only. So it specifies a Linux user that runs commands in the build spec file. So this run as, and then you enter a Linux user name, would grant that user read and execute permissions. Then we have environment. This again is optional, and it represents information for one or more custom environment variables. And notice it's in a key value pair format, and just be aware that it's not good to store such things as our key pairs in files. And in fact, this parameter store provides an opportunity to reference variables that you would store in the AWS parameter store. So that's the safe way to do it. And Git credential helper, well, that's pretty much explains itself. It's optional. It's used to indicate if code build uses its Git credential helper to provide Git credentials. So if it's used, it would just be yes. Then there's proxy. Proxy is optional, and it's used to represent settings if you run your build in an explicit proxy server. All right, now we're getting to the heart of the matter, phases. Phases is required, and it represents the commands code build runs during each phase of the build. So install, pre-build, build, and post-build. So again, we see run as, same as up above, Linux username. This is for Linux. Now, this phases is required, but all of these build phase names, install, pre-builds, build, are optional. So these are the commands under install that code build will run during installation. And install specifically is for building packages, for installing packages in the build environment. An example would be to install a code testing framework, such as Mocha. And then we have pre-build, and you see how this gets repetitive. Optional run as for Linux user, then the commands, and then finally cleanup. And if you're into software, think of exception handling. So pre-build is the commands code build would run before the build. An example would be to sign into Amazon ECR. Then we get to the build. Of course, the commands code build will run during the build. Examples would be Mocha or Maven commands. Then there's post-build, and actually our build spec that we ran in the last lesson in this section used Maven to package our build into a jar file. And again, these finalies if you're not familiar with exception handling, these finallys will run no matter the outcome of the commands. So if it runs successfully, finally runs. If something fails, finally runs anyway. And then we have artifacts. So information about where code build can find the build output and how code build prepares it for uploading to an S3 bucket. Remember our code build output bucket. All right, now let's take a look at the build spec file we've been working with. So there's our version, but first of all, notice that we're skipping environment variables and proxy, and we can jump right into phases. And remember, it's not mandatory to do anything in all of these phases. So for our install, we're installing the Java runtime. Pre-build, we're not doing anything. Build, we're just echoing when we started our build, and then we're doing a Maven install. So Maven's a build automation tool that's provided by Apache. The Maven is really performing the build, and it works with the pom.xml file that we used in the last lesson. So in a nutshell, what it's doing is it builds a project, and it's going to install it to our repository. Ultimately, messageutil.jar. So let's go over to our S3 bucket from the previous lesson, code build output 92619. All right, code build demo project target. There's our target. And then underneath target, we better have a messageutil.jar. There we go. So Maven's doing all the work in here, and the output is to our code build output messageutil.jar. All right. Now let's go over to our diagram, and I'll click on the star for build spec. And here's another build spec example. So we've talked enough about build spec, but certainly check this out offline when you get a chance. So let's do a build in the management console. Now, before doing a build, you want to ask a few questions. So let's click on this star and questions. Where's the source code located? In our case, it's our S3 input bucket. Which build commands do you need to run and in what order? This gets into what we just talked about with our build spec. Which runtimes and tools do you need to run the build? We're using Maven, Apache Maven, and it's producing our jar file. Do you need AWS resources that aren't provided automatically by code build? If so, which policies will these resources need? Well, really, that's a question we always have to ask. So as we go throughout this course, and we've certainly seen it already with code commit and code build, we have to be aware of those permissions. We have to attach policies to users or groups. We have to have service roles to allow our service to act on our behalf on other services. So that's the type of question we're talking about. Do you want code build to work with your VPC? Well, again, those are questions that are not specific to code build, but really AWS. So if we're launching an EC2, we're launching it into a VPC and a subnet. So we have to provide those VPC and subnet IDs. This is the same scenario. Is code build working with our VPC? Well, then we need to track down the VPC ID and the subnet ID. All right, so let's do a build from the management console. So I'll just open up another tab and go to code build and create build project. Give it a name. All right, now this build badge is optional. And what it does is it makes our project's build status visible and embeddable. Now the caveat to that is doesn't apply if the source provider is S3. And we're just going to use the code we already have stored in S3. So for source, we select S3, provide our bucket name. There it is, code build input 92619. Now this object key, remember, is our zip file, messageutil zip. And there's source version, which is optional. OS, Amazon Linux 2, standard runtime, standard image. There's our service role, just some additional configuration. All right, so of course we're using a build spec. There's our build spec in our input file, artifacts, S3, and we want our artifacts in our code build output. This name is optional. It would create a folder. Artifact packaging, let's go ahead and zip that. CloudWatch logs, that's optional. Let's select S3 logs. And let's go with our output bucket in S3. Let's go ahead and create build project. All right, so I don't want these videos to get too long. So I'll end this video now. In the next video, where we'll just have a fresh start and a bit more time, we'll go ahead and run a build, and we'll just talk about that process a little bit in depth. So with that, I will end this lesson. I will see you in the next lesson. Welcome back. So we've created a build, and now what's left to do is actually run our build. And a build represents a set of actions performed by code build to create output artifacts. In our case, it is going to be a jar file. And that output artifact will be based on a set of input artifacts. And that's what's stored right now, our code, in our code build input bucket in S3. Let's work through some of the tasks we can perform with builds. We can, of course, run a build in code build, view build details, view a list of IDs, list of build IDs for a specific build project, and then stop a build and delete a build. Now, what we'll see shortly is that there's not a delete build option in the management console. That has to be done from the CLI. And pretty much described our recipe for success. Understand our build phase and transitions, and use code build to run, view, and delete builds. So let's go back over to our management console. Now, in the previous lesson, we created this build project. A couple of things we can do here. We can, of course, just click on this build. Notice there's no build history yet. We haven't started the build. But another thing we can do is just go over to build history. This build history is specific to all the builds performed in this account. Have some successes and have some failures. And for the most part, this group of failures was on the same project. Testing was not going well that day. Back to build projects, another thing, and it's just the same, but I just want to emphasize this point. If we need a list of the build IDs, again, it's back to build history, and these are our build IDs. And as we work through the course and seen already, these IDs come in handy when working from the CLI. They're usually required to identify the element that you want to work with. Now let's do that one from the CLI. So I'm SSH into the admin machine as Erica. So it's AWS code build list builds. Now there are some options we could add. We could add a sort order, but let's just forego that and run it. And you can see all of these build projects are listed by ID. All right, I'll clear the screen. So if we want details about one or more of these build projects, we do AWS code build batch get builds, and then we provide the ID or IDs. Let me do this one. And there's a bunch of information about that build project. Compute type, S3 bucket, storing some information, account ID, and then it's going through phases here. Download source, install. There's our pre-build. There's our build. Post-build, upload artifacts. ARN for our service role. Build status, succeeded. Ton of information on that build project. You clear the screen. All right. Now to view a list of build IDs for a specific project, and I'll just use this one, AWS code build, list builds for project, and then just provide the project name. And looks like we have two right there. All right. Now back to the management console. Here's our build project we just created in the last lesson. So let's go to that and let's start this build. So everything's ready to go, source provider, and it's showing where to get that input. And then, of course, we've already set up everything to produce the output. So let's start this build and just keep an eye on our progress. All right, so our build succeeded. There's information about our logs, phase details. We recognize these from the build spec, install, pre-build, build, post-build, build details. All right, so let's go over to S3 and we want to go to our output folder. There it is. And here's our newly produced output. Remember, we wanted a zip file. Just wanted to understand the build phase and the transition and things we can do in the management console, and also the CLI, viewing our builds and details about our builds. But the most important takeaway from these last two lessons is just when you're working with code build to have a thorough understanding of the build spec YAML file and what's going on and the elements you need to provide to have a successful build. So with that, I will end this lesson. I will see you in the next lesson. Hey folks, welcome back and welcome to our section on AWS Code Deploy. So what is Code Deploy? Well, it's a deployment